Alright, in this video this is going to be probably one of 5 or 6 videos of going through the problems on the final review. So what we're looking at here is a rational equation. We have 5/6x minus 2x plus 4/3 is equal to 5/3. And what we're going to do is going to simplify it down and we're going to look for the LCM. So we have 6 and 3 as the distinct denominators. Because 3 goes into 6, then 6 is going to be the least common multiple or the least common denominator here. So we're going to multiply everything by 6 or 6 over 1 if it's a fraction. That just kind of helps us out with the multiplication and the cross canceling. Okay, so we'll identify that 6 is our LCM, so we're going to multiply every term, so we're distributing that throughout the equation. So on the first term, the 6's are going to absorb, and then we'll have minus 2x times 6, which is minus 12x. Okay, 3 goes into 6 twice, 4 times 2 is 8, and then equals, 3 goes into 6 twice, 5 times 2 is 10, and out pops a nice linear equation, so we want to solve this by isolating the variable, and so we're going to subtract 8 from both sides. Combine our like terms, we get minus 7x equals 2. Divide both sides by negative 7, and we get x is equal to negative 2 over 7. You can check the answer if you want. Where you absolutely have to check your answer is if you have a variable in the denominator, because we may have some extra answers that don't work called extraneous solutions. But in this case, we don't have any variables in the denominator, so minus 2 over 7 should be a good answer. Okay, so we're going to look at another example here. So this time we have 3x plus 5 minus 5 times the quantity x plus 1. And what we're going to do is we're going to use the distributive property, and we're going to distribute that minus 5 to the x plus 1. And then we will combine our like terms. So that'll give us minus 5x and minus 5, and then we'll write down the rest of the equation. And then we'll combine our like terms. We get minus 2x equals 6x plus 7. Now this is a linear equation, so we'd like to get all the x's on one side of the equation. It'd be a little easier to get them on the left. So we will subtract 6x from both sides, and we'll have minus 8x is equal to 7, and then we'll divide both sides by negative 8, and we'll get x is equal to negative 7 over 8. Okay, so we'll look at another one on the next slide, and it's going to have a nested set of parentheses, and so we're just going to work our way from the innermost parentheses out. So you got bracket parentheses, and then you got regular parentheses inside the bracket parentheses. So that means we'll work that out first. And it's a negative times the 4 plus 2x, or a minus quantity 4 plus 2x. So we can think of that as a minus 1, and we'll go ahead and distribute that in the innermost parentheses there. So we'll distribute that minus 1. Okay, so that'll be minus 4 and a minus 2x. And then we'll just write down everything else in the problem there. So we just did the innermost parentheses. Now we'll combine like terms in the brackets. Get minus x and a minus 1 equals 2x plus, I think it was a plus 2, yeah. And then we'll go ahead and do the distributive properties. We got minus 2x minus 2 equals 2x plus 2. And then this is a linear equation, so we want to get all the variables on one side. So we can add 2x to both sides, and we can also subtract 2 from both sides, and that'll get the x terms on the right hand side and the constants on the left hand side. So we have minus 4 is equal to 4x, and then divide both sides by 4, and we get x equals negative 1. So it seems like a lot of our problems have an answer of negative 1. I guess it's a nice number to come up with. Alright, so we got a couple more. I think I'm going to do like the first 10 problems on the review in this video. Okay, so we're just going to work our way through. Most of this set is going to be linear equations like this, and some radical equations. I think we do one problem with the quadratic formula near the end. Might be the last problem. Alright, number 4. Alright, so we got 1 over 14 times the quantity 3x minus 2 is equal to x plus 10 over x. Now there's a variety of different ways you can solve this. If you want, you can distribute the 1 over 14, but then you got that fraction hanging out there. You can cross multiply. There's a lot of different routes, but we'll go ahead and identify the LCM. So there's only two denominators. There's a 14 and an x. They're distinct, so the LCM here is going to be 14x. And so we're going to go ahead and multiply both sides by 14x over 1. And on the left-hand side, the 14s will absorb, and you have x times the quantity 3x minus 2. On the right-hand side, the x will absorb, and then we'll have x plus 10 quantity times 14. So we'll go ahead and do that distributive property on both sides, and we notice that we're going to get a x squared, so that's a quadratic. So the strategy of solving a quadratic is setting it equal to 0 and hoping it factors. This one's going to have fairly yucky factoring, so you could do the quadratic formula, but it will end up factoring in this particular problem. So there we are, setting it equal to 0, and we're going to do the AC method, so we're going to do a times c. I'm foregoing the minus sign. It should be negative 420. I guess we could put that in here. So there's the negative 420. I'm just going to look at factors of 420, and then we're going to try to find the pair that has a sum or difference of 16. And so I'm just going to go through the list. I'm tired. Divide by 1, divide by 2, divide by 3, divide by 4, divide by 5, divide by 6, divide by 7, divide by 8 won't work, and 9 won't work, but 10 will work. And then usually Dorseri has that little like advertisement thing there. Even though I paid my $30 for a license, it still seems to be there. So I'm going to try to avoid that right-hand corner. Anyways, 11 didn't work, but 12 worked. It was 12 times 35. And then 14 times 30, and that's actually the winning combination. They do have a difference of 16. So we can go ahead and get this set up to do factor by grouping. So 3x squared minus 30x and plus 14x. Now you could have done the 14x first and then minus 30x second. It'll work out just fine. Minus 140 equals 0. GCF of the first two is a 3x, so we can factor that out. And the GCF of the second is 14. Okay, and then we got the x minus 10s in common, so we'll factor that out. And 3x plus 14 is left over. And then we'll set each factor equal to 0, and we'll solve that, and we'll get x is equal to 10, or x is equal to negative 14 over 3. And then we did have a variable in the denominator. It was only x, so x cannot be 0. Okay, so x cannot be 0, but our answers are 10 and negative 14, so we're good to go. Okay, so let's go ahead and take a look at another one. So this is number 5. So we have 3x plus 2 over x minus 2 plus 1 over x equals negative 2, and then x squared minus 2x. And how a lot of these are set up is if I multiply these two together, I'm going to get this one. And but first thing we'll want to do is kind of our strategy is to factor the denominator to kind of look at what we got going on. So let's go ahead and rewrite, and we're going to go ahead and factor the denominator of that last term there on the right hand side. So we'll have negative 2, and then we got x and x minus 2. Okay, so our distinct factors are x minus 2, x, and an x minus 2. So we only need to count the highest power we see. They're all of the first power, so all we need is one of each. So we need an x and an x minus 2. Okay, and so we're going to multiply everything by x minus 2, and then I'm going to go ahead and mention our restrictions. So the two restrictions are x cannot be 0, and x cannot be 2 here. Okay, since everything's a fraction, we'll multiply everything by x minus 2 over 1, and we can decorate the binomials with parentheses to remind ourselves we're multiplying. X minus 2's will cancel in the first term, and then we'll distribute the x. The x times the 3x will be 3x squared, and the x times 2 is 2x. On the second piece, the x is absorbed, and we're left with x minus 2. And then on the right-hand side, everybody absorbs, but we have a minus 2 left over. This is quadratic, so we're going to go ahead and move the 2 over, and then we'll combine our like terms. And it should be an easier factoring problem. Sometimes it's deceptively easy here. You think it's, oh, this is a hard one. Well, just factor out a GCF of 3x, and you got x plus 1. And then we'll set each factor equal to 0. And so what makes 3x equal to 0 is 0, and what makes x plus 1 equal to 0 is negative 1. Now we got to check with our restrictions, and we notice that x cannot be 0, so we got to throw that answer out. So unless we put an x through it or something like that, that would be fine. But we do have a good answer, and it's negative 1 there. All right. So we got a few more to go. Just to hang in there. Maybe you're going to skip on to the problem that you're actually interested in. So let's see what we got going on in the next one. Probably another rational. Yeah, so we got 2x plus 5 over 2 minus 3 over x minus 2 is equal to x. We got two denominators. We got a 2, and then we got an x minus 2. They're distinct, so we're going to go ahead and include both of them as our LCM. And then we're going to go through and mention our restriction, which is x cannot be 2. And so we'll multiply everything by 2x minus 2 over 1, or just 2x minus 2. If it's not a fraction. Okay, so the 2's will absorb in the first one, and go ahead and decorate the binomial with parentheses, and then we'll go ahead and also FOIL. So we'll do 2x times x is 2x squared, 2x times minus 2 is minus 4x, 5 times x is 5x, and 5 times minus 2 is minus 10. On the second piece, the x minus 2 is absorbed, and we'll have, is that an x there? Yes, it is. I have my controls blocking it. Okay, so minus 6x, and that's going to be equal to, it's going to be 2x times x, 2x squared, and then 2x times minus 2, which is minus 4x. Okay, this is quadratic, but it's not really, but we're going to go ahead and pretend it was quadratic. Well, it is quadratic right now, but what happens is, in the process of moving stuff over, so we're going to move the 2x squared and the 4x on the right hand side over, so we're going to do their opposite operations. Okay, so those cancel out, and now we have we got a 5x and a minus 6x, so that'll make a negative x, and then we got minus 10 still hanging out there. So this is not quadratic anymore, it's actually linear. We go ahead and add x to both sides, and we get negative 10 is equal to x, and we can run it by our restriction, which is positive 2, so that's fine. Alright, so a couple more. I think we're going to get into the radical equations. That's where they have the square root, and so our strategy there is to go ahead and isolate the radical and then square it to undo that radical. So here we got x minus 2x plus 3 under the square root is equal to 0. And so the first thing we're going to do is we're going to isolate that radical. And once we have that thing isolated, what we'll go ahead and do is we'll square both sides to undo that square root. Okay, so x is equal to the square root of 2x plus 3. We're going to square both sides. And then we have x squared is equal to 2x plus 3. And so we just mentioned, what did we do? We squared both sides. Okay, and why did we do that? To undo the radical. Okay, and this is quadratic, so we'll move the 2x and the 3 over, and so we'll have x squared minus 2x minus 3 equals to 0. We'll go ahead and factor that, and after we factor that, we're going to get 3 and negative 1, or negative 1 as our possible solutions. Now, like the radicals, not like the radicals, the rationals, the radicals have problems. They're not happy with any type of number, so they don't like being fed negative numbers. And related to that, we want to make sure that we don't have any problems here. So we're going to go ahead and run our checks here, and make sure that this is equal to 0, which it is. And then we'll go ahead and do that with the minus 1, and we get minus 1 minus 1 which is negative 2, and that's not 0, so we throw that one out. That's not a good answer. Okay? I think we got 2 more radical equations, then we'll get into the quadratic. So here we're going to do a little bit more difficult example. So we got 3x plus 7 under the radical is equal to 3x plus 5. And so the radical is already isolated, so we're ready to go ahead and square it. Now, one thing we'll mention is we're going to have to do 3x plus 5 squared. So remember, that means 3x plus 5, 3x plus 5. So we FOIL that, 9x squared plus 15x plus 15x plus 25, which is equal to 9x squared plus 30x and plus 25. So I'm not going to show that work over in the problem, but we do have it over here on the side, and if you missed it, you can always come back and rewind the video for that portion there. So we don't want to clutter it up too much, so you do have it over here, or you did have it over here on the side here. So let's continue. Alright. So radical's already isolated, so we're going to go ahead and square both sides, and we're going to have to FOIL that right-hand side, which we just did. The square root and the square cancel, and we get the 3x plus 7 out of the radical, and we get the 9x squared plus 30x plus 25, and we'll again mention we FOIL. And so we're going to move the 3x and the 7 over by doing their opposite operations, and so we have and we do that because it's a quadratic. We want to set it equal to 0. And we got a greatest common factor here. It is 9. So if we can divide out by 9, it's going to make the factoring or the quadratic formula easier. So we'll go ahead and do that. And x squared plus 3x plus 2. Nice factoring problem. Factors into x plus 2 and x plus 1. And then that gives us x is equal to negative 2 or x is equal to negative 1. And we'll go ahead and run our check, and we'll plug in both our answers into both sides of the equation. So on the left hand side we get 1, on the right hand side we get negative 1, which is not the same thing. So sorry, negative 2, you're not a good answer. And we'll do the same thing with negative 1, plug it into the left side, work it out, we get 2, plug it into the right side, and we get 2 on that side as well. So we got 2 on both sides. So negative 1 is a good answer. Okay. So we're going to look at one more, a little bit more tricky, but I don't think it is as tricky as some of the ones we did when we covered this unit more in depth. But let's go ahead and take a look at it. So what do we got going on here? Square root of 4x plus 5, or is that a 9? I think it's a 4. Minus 6 equals 2x minus 11. I have this little pause button bar over the problem, so I can't see it. It's transparent, but I got stuff that's in the way. You won't see it on the video, but you know, you might be wondering why I can't see the problem if I'm looking at the screen. But I have something that covers it up a little bit. Okay, so we're going to isolate the radical here. So we need to add 6 to both sides. And like the last one here, after we've isolated the radical, we're going to square. But when we square, we're going to have to do a little bit of foiling. Okay, so we'll do that foiling off to the side here after we mention that we're going to square to undo that radical. Or in this case, we'll abbreviate it and call it a rad. Okay, so 2x minus 5 squared, 2x minus 5, and 2x minus 5. So that gives us 4x squared minus 10x and plus 25. 4x squared minus 20x and plus 25. So that's what's going to appear on the left-hand side, the other left, the right-hand side of the equation. Okay, so let's get this out of the way. Alright, let's continue. Alright, so squaring both sides, mention that we'll need to FOIL the right-hand side, and we get 4x plus 5 is equal to 4x squared minus 20x and plus 25. And this is quadratic, so we will move the 4x and the 5 over by doing their opposite operations. So we're going to subtract them both from both sides of the equation. 0 is equal to 4x squared minus 24x plus 20. And we'll mention that our GCF is 4, so we're going to divide everything by 4, which makes the problem easier. Smaller numbers, either for the quadratic formula or for, in this case, we're going to factor. If you can hear, the cat does not like me making videos at home. He's doing some protesting. Okay, so our roots are 5 and 1, but we do need to run them through and check them in the original formula, so we'll check it on the left-hand side and the right-hand side. So checking the left-hand side, we get 5 minus 6 is negative 1, and then on the right-hand side, 10 minus 11 is negative 1. So 5's good, and then we'll plug in 1, and we got 3 minus 6, negative 3, plug it in on the right hand side, and we're going to get negative 9, and those two things are not equal, so we throw out the 1s. So long. Okay, and we got one more. It's the quadratic formula problem. We may not know it's a quadratic formula at the very beginning, but I suspect it's going to be one. X squared minus 4x is equal to negative 2. And we'll go ahead and write the negative boy is uncertain whether he wants to go to a radical party. Because he's a square, he misses out on 4 awesome chicks, and the party is all over at 2 a.m. if you haven't heard the quadratic formula story before. So in order to use the quadratic formula, we've got to set it equal to 0. So we're plusing 2 to both sides. And then we'll be thorough. We'll go ahead and identify our ABCs. So A is 1, B is negative 4, and C is 2, and so we'll drop that into the quadratic formula. Remember, the minus sign does come with a formula, so sometimes people say opposite B, so negative 4 plus or minus square root of negative 4 squared minus 4 times A times C. And then be careful here, you need parentheses around this, so you make sure you square that negative. So you can be a little bit careful there. All over 2A. Okay, so it'll be positive 4 plus or minus square root of 16 minus 8 over 2. 4 plus or minus square root of 8 over 2. Biggest perfect square in 8 is 4, so 4 times 2. 4 plus or minus the square root of 4 is 2, and then there's a poor 2 that's stuck in the square root. And then you can do what some people call V reduce. We cannot reduce inside because they don't mingle with the outside numbers. And so we get 2 plus or minus the square root of 2. That's our answer. You can go back and check it, but there are 3 types of equations that we need to check their answers. They have denominators with variables, radicals, and logarithms. Okay, so keep on the lookout. I'll be trying to upload the rest of the review as in a video format soon.